So chapter 2.1, length of a line segment. And it says here, by the end of this class, I should be able to calculate the length of a line segment. So the distance from one point to another will be fairly important to calculate. So what we're going to do is start off to find the distance from the origin to a point. So let me give you an example here, and let's take a look if we can actually come up with the formula for this. So here, the origin is right there, and that's the origin. And the coordinates of the origins are what? 0, 0. And so let's have another point here. Let's say we have a point at 3, 4, for example. So let's say I have point 3, 4, and I'll call that A. And what I want to know is, what is the distance between the origin 0, 0 and 3, 4? Now, when you look at that, you should already know how to find that distance. Okay? So help me out. How would you find the distance of that blue line? What would you use? You can use a ruler, or?
It's the rise and the run, and then the Pythagorean theorem.
Okay, alright, good. And I guess we don't need to go as far as the rise and the run, but we will use the what? Pythagorean theorem. Because look, you see that line there? I can actually start forming a what? A triangle. Okay, so if I go down all the way to the bottom there, I just formed a right triangle. And if I have a right triangle, I can use the Pythagorean theorem to find the distance of that blue line. Here then is what? The distance of here to here is what? The bottom side. What is it? It's going to be what? 3. Right? So it's going to be a distance of 3. Is everyone okay with that? From 0 to what? To 3. So that's a distance of 3. Now from here to here, what is the distance of that? From 0 to what? 4. So the distance here is 4. And then I do need to find my distance. So I'm going to use the Pythagorean theorem, which is what? C squared equals A squared plus B squared. Now, all I need to do is plug in my numbers, and I should get an answer. So C, my C is what? My C is what? I labeled it what? G. Okay, so my distance squared is equal to what? A squared. What is it? 3. So it's going to be 3 squared plus, and B is 4, so 4 squared. And so now I get here what? 9 plus 16, and that's D squared, and D squared is equal to what? 25. How do I get rid of, is that the answer? Is the distance 25? Of course not, right? How could the distance of that blue line be 25 when these are 3 and 4? That can't be possible. So what do you have to do with this? Okay, you have to square root it. When I square root it, I get D equals what? 5. The distance between the origin and point A then is what? 5. Okay, so here we go. Therefore, the distance between the origin and A, which is 3, 4, is 5. Now 5, whatever, 5 units. Okay? Now, so let's come up with a formula to actually find the distance between the origin and a point. So look at this formula here. This is what we use. Let's modify it a little bit so I can find D. So D is equal to what? What is the distance? What is D equal to? Look down here. What does D equal to? Yeah, the square root of 25. And 25 came from what? A squared plus B squared. So the distance, if you want to find the distance formula that we're going to use is just simply the square root of Now, what did I replace that a with? It was the what? The x coordinate. Okay? And then what was the b? The y coordinate. It was the x value and the y value. So my formula is going to be what? X squared plus y squared. And so that's going to be my formula to find the distance from where? The origin to a point. Okay, so let's do a couple examples here and see if we can use this formula properly and get the answer. Yes, from 0, 0. Okay, from the origin to the spot. Okay, here's an example. Okay, and then here we're going to go distance to origin. And let's do A. Let's do 5, 7. So what's the distance between the origin and A? Okay, let's go. Work it out. So the distance formula is what? B equals the square root of, so the square root of x squared plus y squared. Plug in your numbers. This is your x value, this is your y value. Okay, so then you have what? 5 squared plus 7 squared, and then that's the square root of 25 plus 49. And that's going to be the square root of 74. And that's going to be equal to what? 8.6. So roughly 8.6. Okay? Now. Okay. Let's go with B. And here is question B. And so let's try find the distance between B and the origin quickly. Alright, here we go. And I think unfortunately some of you did it wrong. But okay, so here we go. That'll be a teaching moment. Here is so that's the formula, yes? Okay, we're good with that. Now let's plug in the numbers here. And what would you write over here? Negative 2 what? Squared plus 5 squared. And how many of you wrote that? Okay. Unfortunately, that is incorrect. You should not write that. Okay? It cannot be negative 2 squared like that. Because remember that negative 2 squared is actually negative 2 times 2, which is negative 4. However, this is saying x has to be squared. The whole value of x. And the whole value of x is what? Negative 2 has to be squared. So that means you have to put brackets so that you do what? Negative 2 times negative 2. So it's negative 2 times negative 2, which is 4. Okay? So please don't write it like that on the test. You will lose a mark even though you do the final answer correctly. Because if you write it like that, that is actually wrong. Okay? You need to put brackets here. So what do you get in? 4 plus 25 equals the square root of 29, which is equal to, what do you get? 5.4 units. So again, what I'm going to do is I'm going to show you an example, and hopefully we'll be able to come up with the formula for the distance of 2 points. So let's say I have point at 2, 1, and you have 2 and 1, and then another one at 6, 4. So let's say it's about here, and I'll call that 6, 4. Okay, now, I have to find the distance between those 2 points. So let me draw a line in between. And here's the distance that I'm looking for. Guess what formula I can use? The Pythagorean theorem. So how would I draw a triangle in there? I would go where? From there to where? Here. And from here to here. There's your Pythagorean theorem again. Okay, so there's your right triangle to use the Pythagorean theorem on. Yes?
So you treat the 2 and 1 as like 3
well, if you want to think about it like that, yes. But we're just going to modify the Pythagorean theorem a little bit here. Okay, so here we go. So I have to find the distance down here. And so this is from what value? From what? Here. From 2 to what? To 6. So what is the distance between that?
4.
The distance between here is actually 4. How did you calculate that? 6 minus 2. So 6 minus 2 is actually 4. And so how did you find that value? Delta what? Delta x. That is your delta x. So delta x here is the distance between 2 and 6. Okay, what do you think you have to do for the y values? This is what? 1 to what?
4.
To 4. And so in order to find my distance there, what would I have to do? I have to do delta y. And so what I get here is what? 4 minus 1, which is 3. Okay. So all I need to do now is do my distance formula here and then get my answers. Remember, I'm going to use the distance formula. I'm sorry? Yeah. The distance formula is what? X squared plus y squared. However, in this case, the x, okay, the value of x down there on the bottom is actually 2x values that you have to do what? Subtract them. So here, to get the x value here, you actually have to subtract 6 minus 2. So the bottom value down there is 6 minus 2. And that is the whole thing is squared. Remember, 6 minus 2 is just 4, yes? So it's 4 squared plus, and then you have the y's, which is going to be what? 4 minus 1. And that's going to be squared. And then what we're going to end up with is the square root of 4 squared plus 3 squared. And that is actually going to equal to, we already did this, 4 squared is what? 16 plus 9, which is 25. The square root of 25 is 5. Now, let me write the general formula. So in general, the formula for 2 points the general formula for between 2 points is simply going to be it's going to be D is equal to the square root of where do we get that 6 and 2 from? So it was delta x. Let me just write it out long though. So it's going to be what? x1 minus x2 squared. And what is it going to be here? Plus or minus? Plus. And then we're going to have what? y1 minus y2. And that's going to be squared as well. Now, let me just shorten that formula a little bit to delta x squared plus delta y squared. So that's going to be your formula for the distance between 2 points. Now, does it matter if I put x2 minus x1? Does it matter if I put x2 minus x1? No. However, and even you don't even need to be consistent here. Okay? Because you're going to what with the number that you get inside? Squared. So even though you get a negative number, you're going to square it, you will end up with a what? Positive number. Did you hear what I just said? Pay attention, please. You will always end up with a positive, two positive numbers in the end here. If you end up with a negative number, you know you did something wrong. It has to be positive. Okay. Now, I like to keep this consistent because if I keep it consistent, guess what I have right here? Can I combine it to get another formula here? Another value? What other value uses those two? The slope. So what I can do, if I keep the x and y's consistent, then I can use those numbers again to find my what? To find my delta y over delta x, which is my slope. Did you get what I just said? So if I keep these consistent, if I start with x1 and I start with y1, okay, I can use those numbers, reuse those numbers to find the slope. Okay, which you will have to do later. So look over here on top. What is the slope of this top guy here? What is the slope? What is the slope of this one?
3, 4.
3 over 4. Delta y over delta x. Does that make sense?
Okay, I got you.
All right.
You can go down. You don't need to do that.
No, I'm not.
2 or 7.
It's a 2. Okay, so try to find the distance between A and B here. So it's D equals delta x squared plus delta y squared. Okay, so what I'm going to do here now is plug in my numbers. Really, it doesn't matter which x you put first, but do keep it consistent. So I'm going to start with this x here. So give me -2. Okay, minus, remember, is the difference. -8, and not squared, plus. Okay, the bracket. And when I start the y's, I don't want to start with -12. I want to start with 5 if I want to reuse the numbers. So because I start with -2, I will start with 5. So 5 minus -12, and that's squared. Okay, now, what you end up getting here is what? -10 squared plus, what do you got here? 17 squared. Now, that means that I can now use these two numbers to find my slope. M is what? 17 over what? -10. So that's my slope. Okay, because this is my delta x value. This is my delta y value. Is everyone okay? Yes. No, I didn't need to put the brackets around the 17 because it was positive, but I just put it there anyway. Alright, now, you get what? 100 plus 289. which order you put it here, because what you're going to do is square it, you're going to get a positive number. So you get 389, so the square root of 389. Okay, and then what is that? 19.7. So about 19.7. Is that okay? Okay. So let me sketch what we have so far here. The line starts at 3 here, and then it has a negative slope. It means going down like this. So this is line 1. And this has y equals negative x plus 3. Now, I need to find, I have a point at 8 and 5. So somewhere on here. So here's my point. I'll call it A. And this is 8, 5. And now it says to find the shortest distance. Shortest distance between that point and that line. Now, if you think about the shortest distance, I mean, take a ruler or something, and you think about, okay, how can I connect that dot to this line so the length is the shortest? Well, if I connect it over here, well, that seems pretty long, but look what happens. Getting what? Shorter, getting shorter, getting shorter, getting shorter, shortest. Longer. Do you understand?
No.
Let's do that again. It's getting shorter. It's shortest. Now it's getting longer. Okay? So, let's take a look. Okay? Unfortunately, right? Okay, so the shortest distance looks like it's going to be somewhere around here. Okay, so the shortest distance will be somewhere around there. Now, let me call that blue line line 2. Now, I have to find the distance, right? So let's think about this. What I have to do is find what? Start from the question. It says find what? The distance. So find, okay, the distance. Now, if I want to find the distance, okay, what I need is what? Look. What am I looking the distance from? From A to here, which is, I don't know. So let's call it point B. So I don't know what point B is, but I need to find from the distance between point A to point B. So to find the distance, I need what? 2 points. So I need 2 points. Mainly here, I need to find, basically I need to find B, because I know A already. Do you understand that? Yeah. Okay? Now, listen very carefully. To find 2 points, mainly B, because that's the one I need, I have A already. Tell me what B is. Oh, very good. So what I need to do is find the what? The point of intersection of line what? 1 and line 2. Okay, fine. If I want to find the point of intersection, okay, what I want to do is find the what? Point of intersection. Now, what do I need if I want to find the point of intersection? The equation. So I need to find, I need the equations. Okay. So I need the equations of what? Of line 2. Because I already have line 1. Yes? Okay, so this is our thought process. What you need to do is work yourself from the bottom up. To find the distance, you need 2 points. To find 2 points, you need the point of intersection. To find the point of intersection, you need 2 equations. The first thing I'm going to do is find the equations, then find the point of intersection, which will give me my 2 points, which will help me find the distance. You got it? Okay, good. If you didn't, watch the video again. Okay, so what I'm going to do now is find L2. So let's do that. So what I'm going to do is find L2. So here we go. We're going to find, so I like to say for L2. This is my work for finding the line 2. So for L2, remember I do need to find what first? The slope. So good. So again, I told you, you need to know that without even thinking about it. So find the slope of line 2. What is the slope of line 2? What is the slope of line 2? It's kind of hard to see because my picture's up there, so refer back to your notes. It is the what? The negative reciprocal of L1. Because they are what? Perpendicular. Very good. Okay, so M2 is what? Is negative reciprocal, okay, of M1. So therefore, M2 is actually going to equal to what? Okay? Slope. It's a number. What is a number? What is the slope of M1? M1 is what? Negative 1. Okay? So what is the slope? What is the negative reciprocal of 1? It is going to be 1. Because remember, negative 1 is over what? 1. Okay, flip that. 1 over 1. Flip that again. 1 over 1. Doesn't really matter. Okay? Anyway, you got it? Okay. Now, so now I know the slope of M2. So this is kind of an easier question because such an easy, you can find the slope very easily. Okay. Find now what? Find B. Okay, so if I want to find B, I do y equals to what? 1x. Do I need to write 1x? No. Okay, plus B, I can just write x, yes? Okay, now I need to sub in a point. Which point am I going to sub in? We're going to sub in A because that's the point where? On the line. Thank you. That's the point on the line, so that's the point that I'm going to sub in. So what I'm going to do is sub in A, which was 8, 5? Yeah. Oh, I changed the question. Okay, so let's put that in, and what do you get? 5 equals to 8 plus B. Bring the 8 over, you get 5 minus 8, which is B. So B must equal to negative 3. So there is my line 2. So line 2 is actually y equals what? X minus 3. Now, guess what I have to do? What was my next step? Once I find the equation, I have to find the what? Point of intersection. How do you find the point of intersection? Substitution or elimination. Okay, let's do that. Okay, so I'm going to find, okay, listen up. I'm going to find the POI now. So let me put line 1 right at the bottom. So this is y equals what? Negative x. What was it? Plus 3. Now what I'm going to do is, if I want to do elimination here, I can do elimination by what? Subtraction. That will give you what? Y minus y is what? Y minus y is what? 0. Okay, and x minus negative x is 2x. 2x. And then negative 3 minus 3 is, negative 3 minus 3 is negative 6. Bring the negative 6 over to become what? 6 equals what? 2x. So x must equal to what? 3. So x equals 3 here. So x is equal to 3. Remember, divide both sides by 2, you got x equals 3. Now I have to find the what? The y value. So plug it back into line 2, looks like easier one. So we're going to sub in sub x equals 3 into line 2. And that's going to find my y value. Yep. So that is going to give you what? Y is equal to 3 minus 3? No, it's not fun. Okay, now, so the point of intersection is what? 3, 0. Now, once I find the point of intersection, I forgot totally what I had to actually do in the question. So I have to go back and see, okay, I found my point of intersection. Now I need the 2 points, which I already have. So now what can I find? Find the 2 distances. Awesome. Okay. So I'm finding the distance between what though? Between A and B. Okay, so let's find that. Oh my goodness. Okay, so the last thing I need to do here. Okay, so find the distance now. And this is between what? 3, 0, and what was the point? 8, 5?
Yeah.
8, 5. Okay, and then you do d equals what? Square root of delta x squared plus delta y squared. Finish it up, please. Listen. Alright, so let's finish this question up. And so you got 3 minus 8 squared. I'll finish it on the video and then I'll upload it, okay? But anyways, do try your homework, please. And then we'll continue this tomorrow.
Mr. Hodge, what are the pieces